Okay, now we're going to move on to a large part of DevOps, which is the technology part, and we're going to start by just talking about some basic tools. So before we talk about the tools, let's talk about how they're managed. So infrastructure as code is the manage of infrastructure. It's sort of obvious. That means networks, virtual machines, containers, load balancers, connection topologies. And you use code segments to do this in a variety of languages. For example, command line scripting is a very old form of infrastructure as code. Uh, there are provisioning tools that have specifications, and we'll talk about provisioning in a minute, but Vagrant, CloudFormation, Chef, Public, Ansible are examples of those kinds of tools. And then there are specifications for other tools, like Dockerfile is a way of controlling your Docker configuration and your Docker engine. That's also an example of infrastructure as code. So if you have a script for doing something that's repeated and important that it gets repeated, then it has the following advantages. One is you can invoke it with a single command or a single click. It reduces error due to human mistakes during data entry. No matter how much you know what should be in, you're going to mistype from time to time. Fat fingering. Uh, it allows different team members to share scripts so that not every team member has to know the specific commands to, let's say, provision a virtual machine. They just need to know the script, and somebody else could possibly maintain the script. And it makes the infrastructure uniform and reproducible. Well, if you have a script, all of the team members presumably use it, and then they all have the same infrastructure, and that becomes important when you do integration. And the best practices are that scripts are treated like code. They're checked into a version control system. They're scanned for security issues. They're tested and reviewed for correctness and compliance. That's why it's called infrastructure as code. Uh, it's not free. The scripts have to be developed. They have to be tested. They have to be reviewed. They have to be updated when the tools or processes are modified. Uh, and this leads to longer turnaround time for initial use. Again, the notion is that a script will be used multiple times, so it doesn't pay you to develop a script for a single use. But if you expect to repeat that set of operations, or a teammate to repeat that set of operations, then it does pay. There's also an associated notion called idempotence. And something is idempotent if doing it twice gives you the same answer. So in math, that comes from mathematics, where the identity function is idempotent. You can multiply something by 1 as many times as you want, and you still get the same thing. Uh, it's important that infrastructure as code be idempotent. You're going to have different teammates run the script. You're going to run the script at various times. Uh, uh, if it's idempotent, then it doesn't matter when you run it, it will do the same thing. So a deployment example, a deployment command always sets the target environment same into the same configuration, regardless of the environment's starting state. So sometimes the scripts have to be sufficiently intelligent to look at the starting state and say, do I delete what's there now? Can I update what's there now? And so on to achieve idempotence. And it's achieved either automatically or by reconfiguring an existing. It's achieved by either automatically reconfiguring an existing target or by discarding the existing targets. And IAC scripts are typically idempotent. So one of the phenomenon that you have is with the infrastructure is that it may drift. So an example is, suppose you've deployed 5 instances via some infrastructure as code with 128 megabytes of memory. And now all of a sudden, 3 of them are using 256. How did this happen? Well, somebody noticed that some instances had poor performance and increased the memory allocation manually. And so the question is this bad? I mean, they got, they were having a problem and they fixed the problem. And the answer is yes. So if poor performance is noticed on the 5 instances, now you have 5 instances, 2 are one size, 3 are another. If you notice poor performance, is it because of the 2 smaller ones or the 3 bigger ones? And then the person that's looking at it, who may not know that 3 of them were changed, has to figure out that the sizes are different. So it makes the maintenance task much harder. So infrastructure as code can be used. So the message of that is that if you're going to change something in the infrastructure, do it by modifying the appropriate script and then telling your teammates that you've modified that script and then applying it so that somebody doesn't have to figure it out. They know. Infrastructure drift can cause security problems. Somebody is having a problem and changes the IAM, the setting that controls access, which at least in AWS is incredibly complicated. And so it's easier just to make it default. Everybody can do everything. So somebody's having a problem, they change the IAM, and this may open up a vulnerability. And so again, if it's infrastructure as code and you're changing it in the script, then the script is reviewed and somebody says, no, you can't do that. This is how you should do that during the review. So you detect it by, uh, there are tools that detect it, and there are a couple, and they run during production. I can't pronounce them. That's why you can read them. And so discussion questions, again, offline. How would you decide if writing a script is worth the while from a cost perspective? Another question, you have written a script for some purpose. How do you get your team and organization to adopt it? What would that mean in terms of other roles within your organization? So just because you've done something and you share it with your team members doesn't mean that your team members willingly adopt it. And so there has to be some sort of rationale why you did it. And it has to be convincing to your team members. And why does a declarative language make idempotency easier? So you remember what a declarative language is from the introduction to DevOps, the things you should know. So declarative versus imperative. So most scripting languages are declarative, not all. So now let's move on to an actual tool, which is issue tracking. So an issue tracking is something that tracks issues. No surprise. What's an issue? An issue can be a bug, a desired feature, or an incident. And if you enter that into a tracking database, and then it's given an ID, that ID can be used to identify the code, identify various sorts of activities. So subsequently, the issue might be that there's a feature that you want to have added. You write some code that will add that feature, you put it into the version control system, and you tell the version control system that this is in response to this particular issue. And then that gets passed on. And so subsequently, a new version goes into production, and you can track it back to the rationale for doing it. So that's important from a management perspective. Uh, So issue trackers predate DevOps. If you want to look at them sequentially, issue trackers have been around for what? This is the 20s. They've been around 40 years, as a guess. Long time anyway. Uh, and DevOps has only been around since 2002, more or less. Uh, but they're still used and they're still important. And here's a list of common ones: Issue Tracker, Jira, SolarWinds. And now, moving on to more sophisticated tools, you have a version control system, and that keeps track of modifications to textual files. You shouldn't use a version control system for binary files. Binary files can be recreated from some textual specification. And so you just do text. And the other thing that version control systems will let you do is find the difference between two files, two versions of a file, or even two different files. And in order to do that, it has to look at the text. And they can be anything. They can be programming language. They can be infrastructure as code. Uh, they can be documentation. Version control systems can control anything that has multiple versions, i.e. anything that changes. The version control system stores the files and their modification in repositories, and then the repository is shared with access controls. So every version control system is based on a repository. The basic commands are check out, check in. Check out says, give me a copy of a file. Check in says, here's a new version of that particular file. Uh, version control systems are organized as trees. So trees have branches. So you may have a new branch of a version control system, and that may start off with the old one. So you have a set of code. It's in the version control system. You say create a branch. It starts there. And so it will have the same code as the old one, but then presumably you will modify things on the branch that you just created, and then you have to merge it back in. So there's a notion of a trunk of the tree, which is the production version of the code. So when you're going to put something into production, it should have been merged back into the trunk. Uh, version control systems label the versions. Okay. Sometimes you can just say, give me the latest. Sometimes you can say, depending on your needs, you can say, give me a particular version. And they come in two flavors. They all have repositories, but you have centralized version control systems, such as Subversion, which means that in order to access it, to check in or check out, you have to be online. But what a centralized version control system can do is it can lock that file. So you check out a file, then none of your teammates can check it out. So you can't have accidental overwriting or accidental two people working on the same file accidentally. You can arrange it, but you can't do it accidentally. And then there's a distributed version control system such as Git, where you copy it to uh, your local machine, then you operate on it, and then you would merge it back in. And in that case, two team members can be working on the same file. And so then if you merge it back in and they merge theirs in, then you have to resolve the differences. But it doesn't require internet access. So it was developed when internet access wasn't quite as prevalent as it is now. And so for those periods when you didn't have access, you would get a local copy, and it gets widely used. So there are several different branching strategies. One is centralized workflows, and the teams use only a single repository. And when they want to make a commit, they commit to the main branch. There's another strategy where you have teams use a new branch for each feature. And so you would have various branches, and they don't commit to the main branch, they commit to the feature branch, and then they merge it back. Personal branching is roughly the same thing, but instead of having a branch per feature, you might have a branch per developer. And then an issue becomes with version control systems, do you want to have one repository or multiple repositories? And that's an organizational decision. If you have one repository, then it maintains all the projects. The virtue of that is that means any developer can get access to any code. Again, if you can control that with access controls. And so that facilitates reuse. You know, another team is doing something that's similar. You make a copy of one of their modules, and then you make whatever modifications you need and call it as your own. Uh, it also allows a problem to be fixed. anywhere in the system. So if there's a problem and you locate it, you can check out the appropriate code, fix the problem, and check it back in. Multiple repositories. The problem with a single repository is it can get very large if you're a large organization and you have a lot of systems. So Google has upwards of 1 billion lines of code, all run off the same trunk. Okay, that gets complicated. Uh, Multiple repository are done basically one project at a time. So we're working on a particular application. We have a repository for that application. It may have multiple teams working on it. It may have multiple sources and multiple services within it, but everything in that repository is specific to that particular project. And then the developers can operate independently in terms of libraries and so on. And then, but they still have to merge it. So there's a set of best practices for version control systems. So version control systems also predate DevOps. If you want a timeline, version control systems date probably from the 90s. Uh, and again, DevOps is after 2000. So you want to check something in, you want to say what it's for. Okay, what did I do? What was the issue that I'm dealing with? And put that all into the commit. You do not want to commit incomplete code because somebody else may check it out and then it won't compile for them, or you're introducing bugs. You want to commit a logical unit. So if you are simultaneously working on two different issues, don't commit them together, commit them separately. And when an issue has been resolved, you commit that code. When a single issue has been resolved, you commit the code for that single issue rather than waiting until all of your issues have been done. So there's the notion of the big bang versus the incremental. If you do things one at a time, other people could conceivably take advantage of that, and it's easier. It's conceivable. So we'll talk about this later, but something like 15 to 20% of security breaches are from insiders, people working in the company. So it's conceivable that one of your teammates is an attacker. It's probably not likely, but it's at least conceivable. And some organizations protect against that by saying two people have to sign off on a commit. And so that means that you do a security review of the code that you're about. Two people would, the developer and then someone else would do a security review of the code that's about to be committed. And if it's an insider, if somebody wants to submit malicious code, then they have to have a confederate. So the chances of having two attackers within the organization are less than, or substantially less than the chances of having one. And so that's what the two is. And a side effect is that it requires you have a review before you commit something. And so that's going to increase code quality no matter. Okay, moving on, we get to provisioning tools. So a provisioning tool is one that creates or modifies and then provisions, loads, either a virtual machine or a container at whatever its target is. Or it could also create or modify an environment. So uh, a provider is included in the specification of a provisioning tool. And so that's either implicitly or explicitly. So an example is that I want to have a development environment on my machine. And so a development environment consists of an IDE. It consists of maybe a virtual machine. It consists of some configuration parameters for various things. And I will create that, and I'll mention some provisioning tools in a minute, but I will create that through running a script. So I have some infrastructure as code. I'm told that you want to create your development environment, run this script. So I do. And the script has a target. Okay, so it assumes that the target already exists. And then executing the specification makes this target consistent with the specification. If the target doesn't exist, then executing the specification will create a target. So it may be that you're creating something on the cloud. Okay, well then the cloud provider is in the specification. That's the target. And if the desired software is loaded and put onto the provider that's been specified. Of course, you have to have permissions to do this. So common provisioning tools are Docker. Docker creates and provisions containers. Vagrant, Vagrant creates and provisions development environments, specifically virtual machines. Or the exercises that you've been doing are in virtual machines that are easily created with Vagrant. Terraform creates and manages infrastructure. So Vagrant will manage a single virtual machine or maybe multiple virtual machines, but each one is specified. If you want to set up a network with 3 instances and a load balancer, that's a job for Terraform. So you put it into Terraform. And then it provisions the network for you. There's another one, if you're on AWS, there's something called CloudFormation, which is AW specific. All of the cloud providers have equivalents. So Microsoft Azure has a provisioning tool, Google has a provisioning tool. So provisioning is distinct from configuration management. So configuration management is intended to deal with the following problem. You are an organization, you have what's called a fleet of 100 laptops, and each laptop is in the possession of a particular developer, a different developer. So you have 100 things that you want to keep consistent because consistency is very important. And so that's the job of a configuration management tool. You tell a configuration management tool, here is a master. This is the thing that you should copy to all of the laptops that you're managing. And it manages a collection of instances, and then it keeps them consistent. If it copies it, it's idempotent, and so it will slip in there, and then the person with that laptop will be using the same version as of the software and the same software as everyone else. And that helps prevent infrastructure drift as well. So you can use configuration management tool for a variety of reasons. One is to manage a fleet. Another is, and we'll talk later about disaster recovery, but another one is to keep a current copy of your software someplace else in case there's a disaster in a data center. And there are other applications of that. And so you categorize the instances that are being managed by a configuration management tool. You may be a laptop, it may be a desktop, it may be a web server, and each one of these is registered with the each instance of that is registered with the configuration management tool, and the configuration management tool has a script that says, okay, every night we want to update all the laptops. Once a week we want to update all the servers, uh, all the web servers, and so on. And so it knows where the thing that it's being copied is. So you can think of it as just a big copier. It copies the master into a variety of other locations. Uh, Typically, there's one node for the configuration management tool, and then another node where the master is located. So common ones are Chef, Puppet, Ansible. That list hasn't changed in quite a while, so those seem very stable. So discussion questions, again, offline. What are some security considerations for provisioning tools, specifically provisioning tools? What are some security configuration for configuration management tools? So configuration management tool is going to put things on your laptop. Can anybody just do that? Okay, how does that work? So there's a a general problem. It's existed now since there have been multiple vendors of software products, which is since the 70s. Uh, and you can get locked into a particular vendor. And so think about, if you're an Apple person, think about moving your 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 personal activities to a window. If you're a window person, think about moving it to an Apple. Chances are pretty good you're locked into whoever provides the laptop that you're working on. If it's yours, then you're locked into that particular ecosystem. If it's provided by your organization, then everybody in that organization is locked into that particular ecosystem. And some tools are specific for particular providers. So I mentioned CloudFormation. That's specific to AWS. Uh, let's suppose that you have a collection of scripts that provision things using CloudFormation. And now you decide, you're mad at Amazon. Okay, they're charging too much. You get a better deal from Google or from Microsoft. And so you want to move to Google and Microsoft. You have to worry about the fact that all of your scripts are specific to Amazon. So they all have to be changed to have Microsoft or Google equivalents. And that can get expensive. And so if you're using a vendor provided provisioning tool, then you tend to get locked into that vendor. Some tools are vendor agnostic. Okay, so Vagrant is vendor agnostic. Terraform is vendor agnostic. And the particular script specifies the target. So if you want to move, if you have a Vagrant script and you want to change it from using VirtualBox on your laptop to using AWS, it's not this simple, but it's more or less just a matter of changing the target within the script. Uh, and then some tools are portable. So Chef, Puppet, and Ansible all run on all the cloud providers or the major cloud providers. And so if you have a Chef script, for example, you can use it uh, uh, whether you're running on Amazon or Google or Microsoft. So these are things that you need to worry about when you make decisions about how you're going to write your scripts and what you're going to do in terms of cloud providers. One of the phenomenon that's growing is that people are looking at multi-cloud providers. So all the cloud providers have had failures. And so you want to be able to hedge your bets in case you're an Amazon person and your Amazon region goes down for one reason or another. You want to be able to seamlessly or relatively seamlessly shift to Microsoft or vice versa. And so in order to do that, you have to have set up your scripts and chosen your tools that supports that type of transition. And then finally, let's talk about configuration parameters. So the first thing is that a configuration parameter has almost nothing to do with the configuration management system. Configuration management system could manage a file of configuration parameters, but it would treat that as any other file. There's nothing special about it. So a configuration parameter is a parameter intended to be specified by a system administrator. It's not one that a user will specify. Uh, and it's, uh, an example of configuration parameter may be almost anything. So it could be the URL of the database that you're using. It could be the font that you're using. It could be the color that your background is on. Uh, could be how much memory you're using. It could be your IAM settings. So it could be configuration parameters can be anything that the system administrator or the developer decides to make a configuration parameter. You can go overboard with that. So I mean, a configuration parameter essentially means you haven't made a choice. Right. Well, I don't know whether I want to have the thread pool size be 10 or be 20. So I'll make it a configuration parameter. And I know of, it's been fixed now, but I know of a system that at one point had 10,000 configuration parameters. Installing that system was a nightmare. So configuration parameters, again, give the developer flexibility. That's the positive way of saying it. Uh, and they should be checked by so it becomes an input into the system at initialization. So at initialization, the system reads its configuration parameters and should check them for reasonableness, should have default values in case they aren't provided. And the configuration parameters should be version controlled like everything else. And you can set that by having a file with configuration parameters. You can use environmental variables. So the operating system has, if it's Linux, it has $ things, and those are configuration parameters. You can have a configuration database. So the system is now in development. There's a database that has the configuration parameters that are appropriate for the development environment. Or it could be a specialized tool. So sometimes in Windows, you have to change the resource manager, and there's a tool that lets you do that. But the system has to know how to get the configuration parameters that are set for it. And again, a configuration parameter is potentially a security issue. Not so much that people are going to abuse it, but you might it's very attractive to make things like credentials be configuration parameters. And then what happens is you put the credentials in a script and it becomes much more public than you would like it to be. Somebody did an experiment where they put username, password in GitHub, and I think it took 10 minutes before somebody accessed it. And then GitHub sends you a nastygram if you do that. So if you call something username, password in a script, then it's easily recognizable. But in general, you do not want to put configuration. You do not want to put security sensitive things, credentials and keys and so on into configuration parameters. We'll talk about a tool called Vault, which is a centralized credential manager as a way of avoiding some of the problems associated with having the credentials be managed by individual applications. So in term, again, discussion, what are the trade-offs and the different methods for setting configuration parameters? I gave you 4 different methods. What are the trade-offs? And why would you make background color a configuration parameter? Okay, so that's the end of uh, the first lecture. Oh no, I'm sorry. That's the end of this lecture on tools. And so we'll stop here.